Hi, I'm Brooks Hoffman, and my presentation is the effect of different balls' weight and diameter on distance travel. So a little bit to know before we start going into our experiment is that almost every sport uses a different ball with unique diameter and weight, and whether on the ground or in the air, a variety of forces will contribute to each ball with different surface textures, diameters, and weight. And if in trajectory there's a lot of forces that from the air and drag and all that going along with the ball. And to keep at least one of these forces constant, I created a slingshot. So when I shot it, it would be the same for each ball. And if I was just to throw or kick a ball, the results would be varied, and it would be the results would not be meaningful. And so this is answering a question that I and athletes everywhere have always wondered: how far can I kick this, or how far can I throw this? And this is an answer I'm trying to find for myself. And using the knowledge I have acquired prior to the experiment, I think that if two balls have a similarity in diameter, so they're fairly close to the same size, the heavier one will travel farther. So I created a slingshot. So with my method, I shot each ball out of the slingshot 4 times to get enough results. And to measure each distance, I made an interval of 25 feet and shot and found where they landed by placing a flagpole. And I averaged out all the data that I found when we shot it, and if there are any outliers, I would retake it, because there was probably a problem with my slingshot, like sometimes the cords would get tangled, which would mean it wouldn't shoot the same length. And I used a bunch of different types of balls. I used a basketball, soccer ball, wiffle balls, tennis balls, golf balls, and ping pong balls. And I chose these because they each have a pair. So like a ping pong ball and a golf ball, they're different in weight, but they are pretty close to the same size. And through my experiment, I found that my hypothesis was true, that if two balls have have a similarity in diameter, the heavier one will travel farther. Like here, distance travel for each ball. The baseball did travel the farthest. So here, if you say, here's the diameter of the wiffle ball and the tennis ball, they're very similar, but the tennis ball weighs more than the wiffle ball, and there we can see that the tennis ball did travel farther. And there was only one outlier in my experiment. It was the basketball and the soccer ball. The basketball did weigh a little less than the soccer ball, but it traveled farther. And in terms of mass and diameter, some balls look similar, none were exactly the same, so that helped me give meaningful results. And through data, I collected that if they had 2 different diameters, the heavier one would travel farther. And the only reasons for the mishaps were technical issues, or they could have been outside forces with the weather, like wind, which could have been apparent because we were at the top of the hill. And I could fix these technical errors by paying attention to smaller details, like a fixed spot in the pocket. And for more in-depth investigations, I would try to find how wind, different surface textures, and temperature contribute to each way the ball travels.